Okay. I think we're good. I think we're golden. Whoa. I just have to. Yeah, they said the magic box is still not working. So. He's like, did you get it to work?
I tried to do 4 high number, so range number. And then finally, like, oh wait, it's range. Yeah. Which I guess is I would catch it.
Okay, so let's get started. I'll continue today with a technical lecture. We'll be talking about D3. We'll talk about like the more advanced aspects of D3, like data mapping, key functions, and so on. Last time I gave an introduction to JavaScript and introduction to the standard API, the standard DOM API, and we kind of got started a little bit with D3. You already had a chance to work with that in your homework. So before we start, what are your questions for so far? Everything like understandable? Any organizational questions? there's going to be another lab tomorrow night where we will recap some of the things that I'll be talking about today. And yeah, basically with today's lecture, you'll have everything you need for homework 3. So last time we went through the standard API, but then I couldn't actually talk about this part here, running a web server. And so who knows why we actually need to run a web server to develop? Yeah.
So like when you get fetch data, like you has to call back to something that's serving.
Exactly. And the reason for that is like, so what the answer was, especially when we load data, we actually have to load it from a server. We can't just load it from a local file system. And the reason for that is the security. There's ways of like turning it off. In your browser, you can start, for example, Chrome with command line arguments. But by default, you're not supposed to like load like just an HTML page and load some code from your hard drive. And so to do that, we need to run a web server. And there's a couple of different ways of running a web server. The simplest one is to use Python. Like most of you have probably installed Python, and Python has a built-in HTTP server. So what you would go is you change directory into the directory that you want to serve, and then for Python 2 you run this command here, for Python 3 you run this command here. And then your website will be served on localhost 8000. And so that way you can like essentially develop with the data set locally. So that's kind of like the easy and the easy way to do this, but it also has a couple of downsides. Especially like who's used the debugger before? Okay, so I would say about half of you have used the debugger before. Like, what is a debugger?
Allows you to step through your code line by line.
Exactly. So let's imagine I have a for loop, and I want to see what the state of the for loop is in every iteration. Then I would use a debugger to do that. The cheap way of doing that without a debugger would be like all these console logs that you could do, but that is kind of like more difficult to trace. And so if you want to use a debugger, there's 2 ways basically. You can run a debugger in directly in Chrome. So I can simply say inspect, and then I can go to the sources and like, well, let me open up a simple page. So here I can inspect, then I can open up the sources, and then I can put a breakpoint here. And then once I reload that, it will actually stop at that breakpoint. And will give me like information on hover what the various like variables that I have defined are. So this is a way of like me easily inspecting what is going on. And then I can keep stepping here. Like you see those like step over. This is like one line, of course, so therefore we're done basically already. It's a very simple program, but basically you could use the stepper and then like these like step over next function call, step into next function call, step out of current function, and so on. And so you can like inspect your program as it is executing. And that is an extremely useful thing to do. The other way of doing that is like the console always works and you can do it with any website, but I also recommend that you use an like integrated development environment. Here I'm using Pycharm, which is the same as WebCharm for the web development purposes, but Visual Studio Code is like also a good free alternative. And this kind of like has the benefit of you can like very quickly like run every file. Here I just can right click and say debug this file. This will run this in the browser for me. And now I can actually execute it, so I don't have to run a web server in that case. And I can do breakpoints directly in the IDE. So if I did a refresh here, and now I click on run again, it will drop me into my editor. And the great thing is now, like in Chrome, if I edit something, it doesn't like you cannot save it, right? But if you do it directly in your IDE, you can now change something, edit something, and it will immediately be reflected after reload. And so this is also like pretty, you get pretty detailed information about every of these, every object that is defined, and they can drill down, see exactly what is contained in any of those elements. So, and again, you can do things like stepping. So here I'm stepping over, again, this keeps executing, and now I'm in this D3 enter thing. And so I would recommend for any larger project that you use a workflow like this, where you can easily debug and then change code. Yeah. This is Pycharm. This is from like the same company that makes IntelliJ. They have like a couple of products that have the same base, like WebStorm, Pycharm, and so on. I can post a link to that. They give you a free, like, this is not free, you have to buy it as a commercial developer, but with an EDU email address, you can get a free version. Yeah, but they've been very strict about giving out those licenses recently. So you really have to point to like an open source project that you were actively working on. Yeah.
So you're working with JavaScript, but Pycharm is also for Python, right?
Well, yeah, Pycharm is really for the full stack developer, right? There is WebStorm, which is only for front end, but it's very similar to Pycharm. There's just like additional Python functionality. So if you sometimes also do Python, get Pycharm because it can do everything that WebStorm can plus Python. If you want only ever JavaScript and HTML, then go with WebStorm. But like Visual Studio Code seems to be a reasonable alternative. Like all of my students, I think, are now using Visual Studio Code. I feel a bit just like a dinosaur with Pycharm. Okay. So, any more questions about debugging and running with web servers and so on? Okay, so then let's move on to D3, more on selections, data, scales, and axes. Okay, so we'll start with a bit of a recap because I realized that, and we'll talk a little bit more in detail of what the things that we talked about intuitively last time, what they actually means. So first, let's go over how selections and data mapping work again. So we talked about a select and a select all. And so what can I pass into a select? IDs, element names, and classes. So basically any CSS selector. And that will work just as a CSS selector. So here are 3 examples. For element, like it's just SVG. For classes.classname. For IDs, it's hashtag cancel button. But you can also have more complex selectors here. I can ask select all P spans. So these are the spans that are direct children of P. So here is an example for that. We have this example that we had before. We have 4 paragraphs, and then 3 of those 4 paragraphs have a span nested. The third one does not. Here I'm like doing a D3 select all on P span, and then I'm looking at I'm styling this in blue. Okay, so but what I really wanted to show here, like this works of course. What I really wanted to show here is actually how that looks behind the scenes, because it's useful to understand what a selection is. And so if I open this up in a new page, I can actually inspect this, and here I am printing the selection. And so our selection now is made up of these groups, like the underscore groups, and this is the selection object. And here we have our node list, and this contains the 3 span elements. So these are the span elements that are directly in here. Another way of looking at this would be to go into the specific like paragraph element here, and then say this span element, and then I could ask for what are the properties like of that span element. We'll talk more about that, or I could ask what are the properties of the P element. I'll talk more about this in a second. So this is how like a selection looks like. The underscore groups is what is contained in my selection, and then here I have an array with those, or a list with those 3 different spans. When we do a data join, then we can also look at how the data is stored. And so here we have an example where we have 3 bars, and then I do this run and then apply those 3, apply data to these 3 bars again, and I color style them. So remember, we simply do select all rectangles. Then here I'm logging the selection. Then I do the data binding. And here I'm looking at the bound, like the selection with the bound data, and then we do the styling. So here is some very simple styling. Again, remember that all of this execute here, that is just so I can click a button. So that is not particularly important. That is just so that I can click the button and see and can show you the change between the initial state and the applied state. So if I were to, let's say, remove the execute here, then this would immediately apply, and we would never see the gray bars here. So the interesting piece here is looking, and let's open this up again in a new page. The interesting piece here is looking at what is contained in this. So if we do an inspect again, we can look at the console output, at the selection, and now here we have the enter, exit, and groups. And those are probably already familiar from the function calls, right? The enter function call gives you the element that are new, the exit function call gives you the element that are removed, and the group function call gives you, or not, the group function call doesn't exist, but groups is what you have in your selection by default. So these are the updated elements. And so here you see in my groups selection, I have 3 different elements, and those 3 different elements are rectangles. And so now we can look at what are the properties of this rectangle. And the one thing that I want you to pay attention to is this here. So here is where the magic happens. This is what D3 does to those DOM elements. It actually writes a property underscore underscore data underscore underscore to the DOM element. And this is where your D comes from when you later use it in any function. So this is how the data is associated with this particular element. So if I were to inspect that element here, so I'm looking at this element, and then I'm looking at the properties of this element. I can look up the rect, and then I can just scroll down and look at exactly, and it's at the very bottom, it can look at exactly what is the data. So here we have the 256 bound to it. That is very useful, because if something doesn't look as you want it to be, or doesn't work as you expect it to be, you can look here to see what is the data bound to it and make sure that your data bound is correctly. If your data is correctly bound, but it doesn't look like it, then you have maybe done something wrong with the styling, like with the or with the attributes. So you might have rebound the data, but you haven't called the right selection, or you haven't updated the styling on the right selection. So so this is basically how we then can by using these data fields is what we access when we do this styling, like this attribute with this passes in this data field. And remember, there's 2 ways of writing functions here. The long one, the anonymous function or the lambda expressions, where I write function and then pass in the parameter and then I have an explicit statement, or the short one where I use the arrow function notation. So here, these 2 are exactly equivalent, and I'll be using them interchangeably. Usually I use this unless I have more than 1 line to do, or if I want to add a comment. So in our examples here, if I want to say something about what we return here, then I usually use the anonymous function, otherwise I just use the shorthand here. And then also remember, we had this additional parameter, D and I. So D is this data, and I, what is I? The index, yes, the position of the element in the DOM. So here is kind of like this cheat sheet that I introduced last time. So these 3 different types of selections. We have incoming data where you don't have a mapping SVG or a mapping DOM element yet. That's the enter selection. You have data where you don't have mapping SVG or DOM elements anymore. That's the exit selection. And then you have elements where you have a DOM element and you just want to update them, and that's the update selection. And so what we usually want to do is we want to handle our enter, add all of the basic elements, then handle the exits, probably most likely remove them, and then merge, enter, and update, and then do all the data-driven styling. So that's the process of how you develop D3 visualizations. So Let me see, what is this? So here is like an example of that. We simply do like we have an empty SVG, so there's nothing in there. I select all on rectangles, and remember that while it's not strictly speaking necessary in this case to select on rectangles, it's the right thing to do because you might later have an update and then this will fail if you don't use the rectangles here. Here I'm doing the data binding. I'm binding an array to my selection. Now in this case this maps exactly, and then here I have the data and so on. So this is all very straightforward. We can also look at the enter selection right after data assignment. In this case here, we have the enter here contains these uninitialized enter nodes. So this is where I'm plotting this here, this console log enter. And that's what I see here. So these are these like, they are not yet DOM elements, but these are these like uninitialized elements that will hopefully be assigned at a later point. And our enter node here is like a simple thing. It basically has the data and a couple of other things in here. But this is how an enter selection looks before it is assigned to a DOM element. And then afterwards we can use the append function to actually assign it to a DOM element, and then these elements here, the enter nodes, will be transformed in this case to these rectangles. Okay, so here is an example of handle so both enter and update correctly. So, okay, let's maybe do, what does this line do?
Sets my data if there's any.
Exactly. So I kind of want to do something here. I want to alternate between two different data sets. In like if my data is initialized, this is the ternary if statement. If my data is initialized, it will simply, like I'm asking here, if not my data, so if this is uninitialized, then use this, else use this. So if my data was initialized, this doesn't do actually anything. But if it's not, then it assigns it to this array. Yeah?
Yeah. Are those numbers like coordinates or?
No, just like data I made up. It could be like ages of like whatever cars or anything. It's just we'll talk about how data and coordinates map, right? I chose those data elements so that they can actually like show them. I can show them in pixels. But it could be like 1 million or 0.02. All of that is possible. So this is just data. It doesn't have like we're not talking about the semantics in this case here. Okay, so what this allows me to do here is I have two buttons now. I have like the run button that we know, and then I have the next dataset button. Now I can switch between those two, and this does properly update between those two. So okay, let's look at this. So first, here I'm just adding this button. So that's very simple. Here I'm adding the second data set. So notice that this data set has 3 elements. And the default data, if my data isn't passed in, has 6 elements. So we have a different number of elements in our data set. So then I'm doing like a select all bars. Here I'm using a class. I do the data binding. Here I handle the exit selection. So if I go from 6 to 3 elements, this is the line that does that. This bars.exit remove. So that removes those. How do we handle new elements? If we go from 3 to 6, we do this bars.enter. Like here we now operate on this enter selection. Remember, this is not initialized yet. Now with the dot append rectangle, I'm initializing those uninitialized elements to be rectangles. Then I set them to class bars because that's what I'm selecting on here. And then true is just a parameter of this function. And here, this is the important piece now. Like I'm merging this, the enter selection bars into bars here. Is that clear? So, yes?
If you did the merge but you didn't set it equal, would it still work?
No, but try.
At what point function is going from 5 to 3, from 6 to 3?
So from 6 to 3 is like when I let's say when this function here is called, it calls the execute function here with 3 data points. Then this doesn't, and so it's basically just the assignment to a variable. Can in the enter here, like basically I just appended rectangle and set the class, and everything else I'm doing in the update. You could actually, like, maybe it would be better to set height, fill, and opacity directly in the enter selection, because then I wouldn't redo that all the time. So that might be even better coding style here, to only have the data-driven attributes in the update. So, yeah.
How do we have D and comma I?
Because it's like these variables, the names don't matter, right? I could have this count.
Why do you need two? Why not one?
Well, because the parameter, the order of the arguments matters. The first is the data element, and the second is the index. And if I don't need the data element to get to the index, I still need to specify both arguments so that I actually have a defined I. So you'll see when I don't need an index element, I only say D. But if I need an index element, irrespectively of whether I need a D or not, I will always use D and I. So all that matters is the position, and the second argument is the count. If I don't have a second argument, I don't get the count. Is that clear? Yeah.
Is the scope of the index within SVG or is it within the entire DOM?
The scope of the index is within the selection. And the selection corresponds to the order of the elements in the DOM that I selected, right? So for example, remember the example I had with 4 paragraphs, but only 3 of them matching because they had nested spans. It would be like the first paragraph, second paragraph, and fourth paragraph. That would be your selection. And then your index would be 0, 1, 2 for that. Yeah?
I guess I'm not understanding this. We have count, we're multiplying it by 30 and adding 50.
Yeah.
Is 30, is that just scaling for the length?
Exactly. So I'm basically saying, like, this is like the first bar. Let's say it starts with 0, right? Count is 0. This is 0 multiplied by 30 plus 50. So the y position of this would be 50. Then the second one is 1 multiplied by 30 plus 50. Y position would be 80. 2 multiplied by 30, 60 would be 110.
So once you have a selection, is there a way to treat like individual parts of the selection different? Let's say the first 3 could be blue and the second 3 red.
Yeah, you could do like a modulo operator on your index. You could check, you could do conditional styling. So for example, here I could pass in the fill. I could write a function that is if I is smaller than 3, then blue. If I is bigger than 3, then red. So that you can do things like that easily. Yeah. So I would just basically just do here. Instead of having the steel blue, I would do like D. Well, yeah, I'm not gonna code this now, but yeah, it's gonna like not work immediately. But anyways, this you can do that easily, yeah. Other question? Yeah.
When we select the data for the CPD elements, is there a certain order we have to go in? Is that just sort of SVG, and then you have to select the class, and the ID within that class?
No. Your CSS selectors work on the whole DOM. But what I usually do is use the work on the SVG, as you see up here. That's more convention, but you could just start from scratch. If you do it like this, you potentially avoid any conflicts with naming. If you select on rectangles, if you do it like this, you will only select the rectangles in the SVG that you initially selected. But if you have multiple rectangles in different SVGs on your page, you might select all of them. So this would actually, strictly speaking, I could just say D3 select all the bars, and that would work equally. Yeah.
So why are we having both elements in the DOM already and then adding more to them with data? Why aren't we just doing everything from the data?
Well, that's initially here, I start out with my SVGs that are initialized, but the question is really when you want to update data, right? So let's assume you are you build a stock visualization tool, new information about the rates come in all the time, and so you need to update your data. And then you need to like deal both with stuff that previously existed and with stuff that comes new. Like we want to build like visualizations that can react, like we give them an existing state, or they can start from scratch. That's kind of what we want to do. Does that make sense? Or like a simple example is here, like if I were to say, let's suppose this is the grades of students in class A, and then I want to see the grades of students in class B. Now class B has only 3 students, so I need to make this transition, and I'll show you like a more reasonable example later in the class where we do like a more complex update and sorting and all of this. Okay. So then we talked about transitions, and transitions like are quite easy to do. Here we have a couple. So I start out with a single element. I'm moving the initial element in. I'm changing the color of the initial element. I'm moving it down, and then the other the non-existing elements, I'm letting them grow at their position, and then I can switch between data sets, and I get these dynamic transitions. And now I can click between them, and we have, you notice that there is opacity for remove, and then it fades it in and rows it for an added element. So how do we do that? You have the same function here at the beginning. I do my data binding. So how do we handle new elements? We start with transparency gray, bars of width 0. So here, bars.enter append rectangle, we like x position 0, y position is the index, width is 0. This is like now, remember we are on the enter, so we say we're starting out with the bars being of 0 width. We initialize the right height from the beginning, then opacity 0, so they're completely translucent, we can't see them, and here I just set the class. Then for the exits, like this is the enter, so they start out as like bars of 0 width, so you can't really see them initially. Then here for the exit, we start out with opacity 1, transition for 3 seconds to opacity 0. After that is concluded, we remove the elements from the DOM. Then we do the merge, so now we have the enter and the update selection in bars here, and then we define the transition, like bars.transition, duration 3 seconds, and then we say what is the target, how should they look like after the transition. And so the 3 things are different here. Here we now give it a data-driven width, and we give it steel blue instead of gray, and we give it opacity of 1 instead of 0. And that all happens automatically. And so that's what we need to do something like that. And if we look at this, we can actually see how the DOM changes. See how the values change dynamically, and then things are being added, and now, like at the very end, these rectangles, like if I click on next data set, you'll see first opacity shrinks, and then the rectangles are removed. So that's everything that happens here. So questions about transitions?
So the DOM is their selection, the actual selection. Is that what the DOM is?
No, the DOM is whatever the browser renders. Our selection is a subset of the DOM. So the DOM is everything, like all this, all the HTML that is around, and also the API to program that. We refer to both of that as the DOM. Our selection are like just a list of these elements that we currently selected with our CSS selectors. Okay. Grouping, like as you like already did it in your homework, we use grouping to jointly position elements. So in many cases, we want to apply data not directly to low-level elements, but rather to a group. So for example, let's imagine I have a bar chart that I want to label. That's exactly what we have here. So here we have bars and there's these text elements. And so there's two ways I could do that, right? I could, like the question is, how do I position those elements in Y mostly? Like, can I jointly position all of like both the bar and the text level in Y, or do I have to position everyone individually? And usually it's just easier to like do things as groups that belong together, that always are supposed to be together. And so here this grouping works, and how this looks like, but this the update won't work. So we can see like what these elements look like after I've ran this. We can see that we have a group bar with a class bar group, and that bar group contains a rectangle and a text element. Okay? And so now let's create this. What we do here is like we start out the same as before, and the new thing here is like we map the bar groups. Like here I'm actually selecting on .bar group. This is the class that I'll give to the groups later. Here I define like my enter bar groups, append G and class bar group. Then on the enter bar groups, I append a rectangle. And so this does now for every element in enter bar groups, I add a rectangle. And that here we have a width that is data driven, and our height is 20. And then we have enter bar group append text. We transform it over by D so that it's at the tip of the bar. And we like position like the dy, the text position at bar height half. And then here we handle the remove. Here we merge. And then here we like globally position, like define the y position using a transform operation. So like x is 0, we don't change x, but we change the y position by saying I multiplied by bar height. Okay, and so now we have like done. Notice that I didn't like y isn't actually anywhere defined here. That defaults to 0, and I'm then later doing a transform in a data-driven way. So this works fine for like an initial rendering, but I can't switch like if I switch between two data sets, this doesn't update correctly. It removes elements correctly, but it doesn't update the data correctly. And so, why is that? So what didn't I do correctly here? What do I need to update elements? Which selection do I need to define my styling? Transitions? What's that? No, I need to like do my styling on the merged selection between enter and update. And I'm not doing that correctly. And even more problematically here is that I'm doing nested groups. And so what will happen, like the first problem is I'm doing this data-driven width styling here on our enter selection only, and not on the update selection. So that will not work. But there's a more subtle problem at the same time here, because we have like elements that are nested. Our group elements and our contained elements have, like each of these DOM elements has the data bound separately. So the rectangle has the data bound, and the group has the data bound, and the text element have the data bound. So we have the data bound 3 times for a single bar. And if I don't handle this correctly, I get into situations where here the group element was actually updated correctly. We see a data of 100, but then one of the child nodes, the rectangle here, still has a data of 61. So we've updated the top level element, the group, but we haven't passed down the data update into the nested rectangle element. And so we have to completely redesign this program to actually do this properly. So first, here we take care of entering elements. We create the G's. Here we append rectangles and initialize them with a width of 0. And like others, like default initial variables. Then we append the text. So this is kind of like our enter. Notice that there's no data-driven styling here. I'm just creating the elements and the structure. I'm not positioning or styling them in any way based on data. I'm doing the remove, then I'm doing the merge. And now for the bar groups, this is the function that updates the Y position by doing the translate in Y based on the index. And then here is the trick to actually propagate that down and to select a sub-element in the group. So I'm now running bar groups.select rectangles. And now I actually, like after I've done that, I have like my temporary selection here are the actual rectangles. And that select also propagates the data down into the rectangles. And now the data here is correct. And if I do the width, data-driven width styling, then this will work just fine. Here I'm doing the same with the text. Data-driven destyling. Notice that I do this bar groups.select text. And that again propagates that down. And if once I've done that, I can simply run that and then switch to the next data set, and all the labels and updates are handled correctly in this grouped in these grouped elements. Questions? Yeah.
Can you scroll up just so when you select the text and you select the rect, you don't have to bind the data again because it's already bound to its parent group. Is that correct?
Exactly. But you have to call the select to propagate it down.
So sorry, just to be like super clear on this, the only difference between the last one and this one is that you didn't do the select. You didn't select the rectangle.
So two major differences are the first, I did two things wrong in the first example. I did all my data-driven styling on the enter selection, and if I do that, I will never get an update working correctly. But in addition to that, I also did not propagate the data down the hierarchy properly. And by doing like here, all of these bar groups, this is after the merge, and that's the important part. The data-driven styling happens after the merge, and the second important part is that I do the select. And that allows me to access these nested elements, and that propagates the data down. Okay, so one of you guys here, I think you asked earlier, what are the data elements, right? And so the data elements, they can be arbitrary. We've only worked with arrays here so far, but I've conveniently picked arrays that have data points that are meaningful in pixels, right? I can see 127 pixel, I can see 61 pixel, I can see 256 pixel. But we haven't talked about how we work with data that doesn't fit perfectly without any transformations onto your screen. And so the simple solution to that is scale. So here is a data set that doesn't do that. So I have 0.3, 0.01, and 1.5. And I do it's simple data-driven styling here. I click a run, and then you see here is a little rectangle. Obviously not particularly useful visualization, but these could be absolutely useful elements. So what we need is we need to define a function that maps the input of a dataset D to a derived dataset D prime that is meaningful in our pixel space. And we can simply do that. We can choose these f's manually. It's very easy to do, right? So here I'm defining a scale function, and I'm saying for input return input multiplied by 500. And then instead of directly setting width here to D, I'm returning scale of D. Okay, that's the only trick here, and that's 3 lines of code. Very simple approach. And if I run this, I now have the same data set as before. You can see here like 0.3, 0.01, and 1.5. This works just fine. Here I have my scale function. So that's a way to do it. And basically, D3 provides us predefined functions that make it a little bit easier. But what it actually does is just that. So there's like a little, like there's a couple of tricks and a couple of special scale functions. But mostly, like this is the key of like everything that we care about. We have a scale function, and instead of directly applying the data to some data-driven styling, we use that scale function. So why do we want to use D3 to do something as simple as that? Well, there are other kinds of scales that are a little bit more complicated. For numerical data, we could have, or for just positions, we could have logarithmic scales, power scales, or discrete scales. We want to have color scales, and then suddenly translating a number into an RGB color is like something where you already need to write a couple of lines of code, saturation, or anything like that. There's just like a lot of useful functions in D3. And so here is like the first D3 scale function that we use. So here we have like our data set as before, not really visible in coordinates directly. And so here we're defining our x scale. D3.scaleLinear, which means we have a linear scale. We set the domain and the range. And the domain here defines the value range of the input data set. So that's something where you have to think a little bit about what are your scales. And we'll talk about on Thursday what are good scales and what are good designs here. Like for this bar chart, I'm using a scale from 0 to the maximum of the elements in our data point, which seems reasonable. But of course, I could put in anything in here. And then our range here is to defines the output range. And so here I'm saying this goes from 0 to 700. So after I applied this x scale, what does 1.5 correspond to? 700, exactly. Because we've defined the scale so that the max corresponds to 700 and 0 corresponds to 0. So very easy. And then here we call the scale, like just as we did before with D. And so if we run that, we get something that we did before. And then if we modify, let's say this here to 500, we can see that we now have a slightly smaller bar chart. If we modify this to 100, we have like an even smaller bar chart. So that's the way of how you define linear scales. So let's go back here. I could then define a logarithmic scale. I'm taking this out. I'm putting this in. I also have to replace the domain because 0 is not defined in logarithmic scale. And now I'm using a logarithmic scale for the same data set. Of course, this is like I need axis. We'll talk about axis next, but this is like, of course, the difference between 0.01 and 1.5. Like on the logarithmic scale, it makes sense, but you need to be very aware of that being a logarithmic scale. Sometimes depending on your data, like D3 and max and D3 min are useful for your domain, to define your domain. And sometimes you will have to do that manually, like starting at 0, for example, as we did just now. So what happens when you have values that are larger than your domain? So here I'm setting manually my domain from 0 to 1.5. This code snippet here, but I have a data value here with 2. And so what will happen, it will just render over it. So I added this rectangle here with exactly 500 pixels wide, and so we see this renders over that. This is like not ideal, right? If I can't predict exactly what my data is going to be, maybe because of streaming data, I kind of need to worry about this a little bit. And like one simple trick is to simply clamp your data set. So here I'm now saying clamp true, and then basically what this does, it truncates everything that is bigger than that value. That's of course now pretty sneaky, and you should do that only in combination with taking care of this in some extra way. So like in real life, you would probably render a glyph on top of here and indicate this is a broken scale. Or you would make it another color or something to be very explicit about that you've broken the scale here. But that can be useful to sometimes deal with outliers. So now let's look at color scales. We want to do this here. I'm creating a bar chart that has both positive and negative values, and I'm creating a redundant encoding of both color and width. So here we have very long bars are very saturated, and we have like a diverging color scale from red in the negative to gray at 0 to dark blue in the positive. And so we use width and the color scale here to do that. So how do we define that? Well, it's actually quite convenient. We say color scale is D3 scale linear. Domain is from min to 0 to max. Notice that we have now 3 points instead of 2, where we had min and max earlier. We now have 3 points. And then we say from what is our range. And here we can use color names. We can also put in any RGB value, and D3 will do a linear interpolation between them. And I'm saying dark red, light gray, steel blue. And that is like now essentially makes it from the minimum of data to 0, it's dark red to light gray, and from 0 to the maximum of the data is light gray to steel blue. That is what a scale does. In addition to that, I have my X scale, as I had it before. That's similar. Here we have a range from 0 to 800. And then here for the X position. Here's a bit of a tricky part. For the X position here, I don't want to start at 0 anymore, so I have to be a little bit smarter about my X position. And so my X position here starts at D if D is negative, else it starts at 0. And that's what this here does, and I'm applying the scale to that. So basically, I need to like either position this here or at 0. Okay, so whatever is smaller, is it 0 or D? That's where I position the left side of the rectangle. Then I'm doing simply the Y. This is just an index-based spacing. And then here for the width, I'm using an absolute of x scale D minus x scale 0. And that is like the width of these rectangles, so that we can deal with both negative values and positive values. And for the color, that's easier. We simply put in color scale and the D value. And that's all we need to do here. That does all of this for us. Questions? Yeah.
So if you simply take away the return color scale, it's not going to have a color scale, right?
Yeah, it might be black. Or not existent. Yeah, black. The default color. Okay. So now we've always one principle in visualization is that of course we always need to see axes, because then we can actually understand what the values are. Axes and legends. And what we want to do is we want to create an axis like this. And again, you could do that by hand, but D3 provides neat functions to help you do that. And not surprisingly, axes and scales really work well together. So to define a D3 axis, you also need to use a D3 scale, and you pass the D3 scale into the D3 axis. So here's the important piece here. I'm saying let the x-axis be D3 dot axis bottom. And so now I've initialized an empty x-axis which has the ticks formatted so that it fits nicely at the bottom. There's like the axis top, of course, too, and axis left and axis right. X-axis dot scale, and here I'm setting it. I'm setting the x scale, which I have initialized here. So this is like from domain minimum to maximum, range 0 to 800. And so basically what this will give me it will look at the smallest value in this data set here and start the ticks at that and end it with the largest value in that data set here. So you see this goes from like minus 1.2 to plus 1.2. So if I do it like this, and so, okay, let me mention a couple of things here. I do here is just the bar chart that we had before. Then at the end, I do this svg.append group and then call axis. And this is kind of a convention that creates the axis and adds it to the group element which has been added to the svg element here. So this does all of that for you. Like now this axis, however, isn't perfect, right? So we see that like here we're missing the minus. Then we have like this ugly two ticks right next to each other. Here we're actually drawing a little bit over the canvas, and the lines or the labels like overlap with the bars. But generally, this is an axis that works just fine. So how can we like style this axis a little bit better? So here we have in these axes have a defined class, and you can simply say .axis in CSS. And then style it in some way. So here I'm saying axis path, axis line should be green and stroke width of 1. Axis text should be serif and 14 pixels. And then here I'm doing a couple of other things, but now you can see that our like the line and the path elements in the axis are green, and the font is bigger than before. Like you see here, the font was smaller. So that's very simple. The other thing that I'm doing here is I'm also like in practice, we've always started at 0 here, but here now, like I'm actually like adding padding and all of these things, and I'm positioning the axis correctly. And so there's many different ways of doing this, but basically here I'm defining the height and the width of the drawing area, and then I say like I have a padding of 25, and then I set the SVG to be width plus 2 times the padding. So my SVG is actually bigger than my drawing area. Then I do like this gray rectangle in the background, which is like positioned, like has width and height, and is positioned by padding. So this is the gray rectangle here in the background. And then here is the data-driven part of it. Like we've gone through that. All of this is the same as before. This here is new. We say this axis is classed with axis, so that our like style here matches, and then we transform it down, like we transform it over by padding, and we transform it down by height plus padding, and then we call the axis, and then we get this this nice axis. One other thing that you might notice is that I don't have the ugly double ticks here anymore, and that is because I've used the nice function here. So T3 by default does exactly what you ask you to. My axis goes from minus value to plus value. But you can say T3, hey, just do your best to make it like a reasonably like human readable axis, and don't show me like a value of 1.23, but round it to the next usable whatever number, or not necessarily integer, to the next usable human readable number. So you can see it actually did from minus 1.4 to 1.4, which is much smarter than what I did originally. Because like here now we have a symmetric axis. So nice is usually nice to have. So we've only worked with arrays, or maybe any other questions about axes and scales before we move on? Yeah.
This is more about just how you go ahead and actually apply the padding to some of the bars. It looks like you go ahead and translate it as an attribute inside of the bar. Is there any reason why you might not put, I guess, the bar selecting under a group already? And
Yes,
just translate
that
it?
would be more elegant. I would do it like this if I thought of it.
Okay, but you can do it either.
Yeah, I think that like basically what you want to do is you want to think in your coordinate space and not worry about the padding when you render. So here it would be a little bit more complicated code, but it would be better. Like you would create a group element that contains all of the bars. You would translate that over, and then you can work within that group element. Yeah, definitely the right way to do it. The reason why I didn't do it here is because I'm trying to keep those like atomic to what I'm talking about, but generally this is definitely the right thing. Other questions? Okay, so far we've only worked with arrays, but it's rare, like these arrays don't have any data semantics, so usually we kind of like have something a little bit more complex than that. And so here is a long example, and then this is the last thing that I want to do today, but I'll just show you first what this is. We have, I made up a data set that has different like groceries like apples, bananas, plums, bread, cereals, beer, and wine. And then how much of it in weight, like in kilograms or tons, is being sold in the state. So for example, here we have a few cereals, like not a lot of cereals, not a lot of bread, but lots of beer, wine, and fruit. And so what we have here is like numerical values, we have labels, and then we have categorical values. Is it alcohol? Is it cereal? Or is it like is it like dry food or is it fruit? And so the data that we have to represent that is something like JSON, but it's basically just an array of objects, right? So here we have product, apples, tons, in a numerical value, and then type fruit, grocery, alcohol. And so we haven't used this kind of thing before. And so there's a couple of things that are tricky about this. And so like especially what I want to do is now, I want to use a couple of different ways of sorting this, right? I could ask, sort this by type, sort this by product name, so alphabetically, or sort this by weight. And I want to be able to ask all these questions and dynamically update that. And so there's a couple of things that are tricky about that, and this is kind of like a best practices example here that you can use when you build something like that and work across it. And so I'm also going to introduce a couple of things in this example. So the first thing is how do we access data and objects? How do we sort data? How do we properly deal with padding in an SVG? We had an early example, but this is going to be a little bit more sophisticated. Then what we've also done is so far, every bar chart we rendered, we simply used index multiplied by width of the bars to position them, but there's actually a dedicated scale to deal with that. It makes it a little easier, so we'll do that. And then the next question is how do we update a scale? So we've, as data is updated, we also might have to update our scales. And so we'll talk about that. And then the most important and I think most complex thing that we'll talk about is how do we ensure object consistency for transitions and updates with a key function to the data binding. So maybe I'll start with this most complex part and show what would go wrong if I don't do this. So here, I'm going to ignore the right way to do it for now. So if I just did what we did before, and then ran this works fine. But now if I want to resort, do you know something? So did that make sense as a transition? So what's going wrong here?
The values are changing.
What's that?
The values are changing.
Exactly. So my D3 identifies the first element, and the first element between when I switch from type to product, the first element here is beer, but now the first element is apples. And so it identifies, you have updated the data. Zero index element at index 0 corresponds to my new element at index 0, and it kind of loses the consistency between, where has apples been before, where's beers afterwards. So by default, if you update the data set, D3 uses the position in the array to do that. Like if you pass in an array with 5 elements, and then you pass in another 5 elements, it assumes that element 1 is still the same as before, it's just the data value has changed. Is that clear? If we have, however, element 1 suddenly moves to position 3, then we need to worry a little bit more about how to do that. So how could we do that? Anybody have any ideas? Yeah.
I think when you're doing the, like you give it, like you're doing the scaling or the position functions, do it like according to, like have like a manual mapping using like some sort of object ID or something, or I guess you could drop the name on this because that's PDF, but.
Exactly. So instead of the default identity between those two updated objects, which is the position in the array, we can tell D3. This is actually what you should use to compare identity. And so the way this is done is by passing in a second parameter in the data function. So here these are just data as we used to before, but here is the version that actually does this correctly. So here we have select all.bar group as before, then our data. In data, the first parameter is the same, but now we can pass in a function. And in this case, our function, like we take like the function d here. This is like each of these elements refers to each of the elements in our data set. And we say d.product is we want to use to identify equality. Okay, is that clear? Like d.product, we know that every object here has like a product. And now we tell D3 to compare between two objects or to identify how an object has changed or moved around in our index. Don't use the index, but use actually this identifier. So that's all we need to do. And that's something that in most cases, if you do something with sorting, this is what you always have to worry about. Is that clear, or any questions about that? Yeah.
So it looks like this is literally taking the product and using that as the data only.
So no, it uses just the full data set. So let's look at them. So it uses the whole object. Every object is bound to every DOM element here, like directly, the whole object. But it tells you to identify equality, use the key that I explicitly specified instead of the index. We can look at this in the inspector. So by what we do here, we have a rectangle, and then if you look at the properties of that rectangle, we'll see that our data here is actually the full object. We don't have a single value here anymore, but we have an object that has product, tons, and type. So this is different from before. Before we had like a simple data type and number, and here we have an object that is assigned. And that is assigned to every element here, like the matching object. And so I basically associate an arbitrarily complex data structure to every single DOM object. And then I can use, and I think that's the next important part on how do I use those. How do I use those data? How do I use those data? These objects in our when we try to do data-driven styling. So this is the key part here. Now, for example, for the text, we say it's not just D, right? It's D.product. We access the product label of our object to be our text. Or equally here, for the height, the width is what I'm looking for here. For the width, we're actually not using just D, we're using D.tons. So like, this is actually unnecessary because I copied it from the previous example, but since we have only positive values, I could just do x scale D.tons. Is that clear for everybody? Okay, so then maybe let's just go like these are the important parts. Like here is the objects. I bind each of these objects to one DOM element. I can access them with the dot notation or with the bracket notation and the string, which you shouldn't do usually. But let's go over the rest. And so here, like I'm also, I could have like just like identified all the types from our data. Like in practice, this is probably what you want to do. You want to write a function that identifies all your types automatically. Here, I was just lazy and like copied them manually. Then I'm looking at the max, the numerical max, and so here I'm using d3.max with an accessor function. So here, similar as before, I'm passing the whole data, this list of objects, but I tell d3 max, I don't want to have like the maximum of these objects, which is not meaningful. I want to have the maximum of these objects in the field tons. And so this is our max value here. Here I'm defining our margin object with top, right, bottom, and left. Here is like how I define our width and the height. Is 800 minus margin left and right, margin top and bottom. Then I'm creating our SVG element, which I give the width plus margin left, plus margin right, the height plus margin top, margin bottom. And then we do like a G element, as you just suggested earlier, where we have all of our elements in there and then transform that over so that we can use like a simple calculations and don't have to worry about the padding anymore. Here's some spacing that we use for labels. And then here we define our X scale for the bars. Here we go from 0 to max. Remember the max we defined earlier based on the weight attribute. Then our range is from text width to width. That is kind of like, we want to start out, like what we see here is we don't want to start out from 0, even with after the padding, but we want to start out from a little bit over there because we need space for the labels. Then we have our color scale, and here I'm actually, now we've used earlier we used a continuous color scale. Now I'm using an ordinal color scale, so that means a categorical color scale here. The hue is varying. And so I say d3.scale ordinal, and then I say domain is my types. And this is a list of discrete elements, right? These are like fruit, alcohol, and grocery. I'm saying range, and this is a set of predefined color scales, colorbrewer.accent with 4 categories. And I'm importing this color brewer here. So this is like another script that I import that is not part of the D3 core package, but these are just supplementary color scales. And so this import statement allows me to access that here, and accent is one of the color scales, and I'm saying I want the accent color scale of length 4. Then here, this is the next new piece, scale bands. And we'll talk more about scale bands because you will need them for your homework in the lab. But scale bands are something very nice for dealing with bar charts, because like the tricky bit about bar chart is like how wide is the bar chart and how much gaps do I have between those bars, and then what's my padding on the left, my padding on the right. And these band scales simply do all of that for you. So you have a range, and then you have a bandwidth, and then you have a padding. And that makes, like, you can access those things directly, and that makes it quite easy for you to do. So for example, if you want to position something, like 1 over, you say 2 times step size. But if you want to draw the bar, you say its bandwidth, and those two are slightly distinct and consider the padding. And so that makes it easier to draw bar charts. And so here is what I'm saying, d3.scale band does range from 0 to height, and then padding is 0.1. So I want 0.1 padding in between them. And so this is now the spacing here. The 0.1 is that, and height is like what I defined earlier, is like this space here. Here I'm defining the axis bottom. Then I am assigning the axis. And so this was everything that was not data-driven. This was all the precursory steps. And now the next part is how do I actually do the data-driven drawing. And here we see how I do update something. And the Y scale here is our band scale, our scale band, and that's what we are updating. If we are sorting, we are updating where these elements are on our Y scale. And so we need to actually, we assume that data here is correctly sorted. And so we are saying every time we run this execute function, update my Y scale to correspond to the order of elements in data. And I'll talk about how we sort data at the very bottom, but just assume that when I switch between type and weight, that data is being resorted and execute is called with an updated data. So that's how that works. And then here I'm simply saying Y scale domain data.map is the, and here I'm of course our Y scale is discrete, and so I'm setting it to be the product. Then here we create those bar groups, and this is the key binding that we talked about before. Here we do the actual data binding, and this is the key that we talked at the very beginning. And then here we have the enter and enter animation. So we append the G, we set it to a class, and then we move it over by our Y scale. Here we use the Y scale to place it at the correct position. We look simply up what is the position of our data element according to the Y scale, and we identify that by the product name. Then we append the text, opacity 0. We append the rectangle with 0. So these are just in our initialization, in our enter. Then we deal with exit and remove. We don't actually have that here. I just added it for completeness sake. And then we merge. And after the merge, we do all of the data-driven styling. So first we do the select text. Remember, this down propagation into the group element. This is how we do that. And then here we set the text to be d.product. And then here is this is just to properly align the text in the middle of the bar. There's a couple of tricks here. I'm moving it by bandwidth half, and then set the text anchor or the alignment baseline to middle. So I'm saying move the text up half the bar and align the text in the center, and that will easily perfectly align the middle of the text with the middle of the bar. I'm doing a transition, and I'm setting this to opacity 1. Then for the rectangle, I'm using Y scale bandwidth to define the height. Remember, this is what I talked about, these fancy scales. Here we have the bandwidth, which is a little bit shorter than the step size. And then you use our color scale based on the type to style the color, to style the fill. And then here we simply, after a transition, define the width based on the weight of the sold products. And then here, this is after our animation, if we update, this is now positioning those groups. That simply translates it by the each of these groups by the Y scale. And so this is this is what does by using this transition and duration. This is what does this nice sorting transition here with object consistency. Okay. And the last part about this program here is how do we sort? And the sorting is this is actually independent of D3. I'm listening to a change on the sort selector, and then I define a sorting function. And depending on whatever the active element in my drop-down box here is, weight, type, or product, I'm simply listening for that. And so I retrieve that by d3.event.sourceElement.value. This is what the event triggered, and that's kind of a data is kind of what I get assigned to active here. And then I'm using a sort function where I compare A to B and then switch over active. And in case of product and type, use lexicographic sorting, and in case of weight, use numerical sorting. And then after this event was triggered, I call the execute function, which goes in here and then does all the data-driven styling, including the transitions. So a little bit complicated, a little long, but there's like, basically this is a bar chart. For this data type, you thought about everything. So questions about that? I'm expecting you guys that you have to like study that a bit and play with it. Yeah. What's that? For what? The homework? Well, it's not that complicated, but I don't think the homework is hard. You should be able to do it in a couple of hours. Okay, thank you guys.
Like